Geometry Basics, Transversal and Slope.
For our first topic, we are going to talk about special angle pairs. Before we talk about theorems, we need to know about transversal angle pairs. First, what is a transversal? A transversal is defined as a line or lines that intersect at least two lines at least two different points. This is a transversal line. The T is a transversal, intersecting both lines Q and R. Now there are special angle pairs that are the names for the angles that are included with every transversal line. Four interior angles lie in the region between lines Q and R. The angles are angles 3, 4, 5, and 6. Interior angles always lie in the middle of the two lines no matter what. Four exterior angles lie in the two regions that are not between lines Q and R. The exterior angles in this diagram are 1, 2, 7, and 8. Exterior angles are always on the outside of the two lines that are intersected by the transversal. Consecutive interior angles are interior angles that lie on the same side of transversal T. In this diagram, angles 4 and 5 are consecutive interior angles, and 3 and 6 are consecutive interior angles. In general, consecutive interior angles are always on the same side of the transversal, not separated by a line, and are in the interior. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of transversal T. Alternate exterior angles in this diagram are 1 and 7, and then 2 and 8. Essentially, these are alternate interior angles, but just changed to exterior, meaning they are on the opposite side of the transversal and travel down the transversal to the next angle. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of transversal T. Angles 3 and 5 are alternate interior angles, and so are angles 4 and 6. So in other words, the angle that is on the other side of the angle that moved one angle down is the alternate interior angle. Corresponding angles lie on the same side of transversal T and on the same side of lines Q and R. The angles that correspond in the diagram are 1 and 5, 2 and 6, 3 and 7, and 4 and 8. So in other words, it's the two angles on the same side of the transversal that add to 180 but are not adjacent to each other.
We chose this chapter for our free choice topic because it's the second most important topic in chapter 3. Knowing what the special angle pairs creates a strong base for the rest of the chapter with the theorems and postulates that include the angle pairs. Speaking of theorems and postulates, let's learn about them.
Special angle pair relationships, theorems, and postulates.
To understand special angle pair relationships, let's refresh our memory on parallel lines. Parallel lines are coplanar lines, meaning they're on the same plane, that do not ever intersect. This is what a parallel line looks like. Parallel lines are important because the following theorems and postulate require a parallel line to be true.
First, corresponding angle postulate. If parallel lines are cut by transversal, the corresponding angles are congruent.
In this diagram, lines Q and R are parallel. 1 and 5 are congruent because of the corresponding angles.
Next, alternate interior angles theorem, or known as AIA. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent.
In this diagram, angles 4 and 6 are congruent because of AIA.
Next, consecutive interior angles theorem, or known as CIA. If two parallel lines are cut by transversal, then each pair of consecutive interior angles is supplementary.
In this diagram, angles 3 and 6 are supplementary because of CIA.
Lastly, alternate exterior angles theorem, or AEA. If two parallel lines are cut by transversal, then each pair of alternate exterior angles is congruent.
In this diagram, angles 1 and angle 7 are congruent because of AEA.
When studying the proofs, these theorems and postulates are very helpful. A good way to remember them is by their acronyms. CIA, which is supplementary, AIA, which is congruent, AEA, which is congruent, and CA, which is congruent. The difficult part, though, is whether the theorem is proving the angle congruent or supplementary. Remembering both what each angle pair is and the correct theorem can prove hard on the test when you have to recall a lot of information. But these theorems and postulates are extremely important and will be referred to again and again throughout your math career.
So now, we're going to be learning about slope.
In a coordinate plane, the slope of a line is the ratio of change along the y-axis to the change along the x-axis between any 2 points of a line. To find slope, the equation is y2 minus y1 over x2 minus x1. Always remember, rise over run. Let's do a problem. Find the slope of a line containing the given points, c3, 1, d, negative 2, 1. Let's use a slope formula and plug in the numbers. First, for the y's, y minus 1, and the x's, 3 minus negative 2. That gives us 0 over 5. That means the slope is 0.
Slope is used from algebra basics to complex calculus. If you don't understand slope, the rest of math will not make any sense. Proving lines parallel with slope will allow you to then find the special angle pairs and their relationships. Proving lines perpendicular and much, much more. Slope was one of the core basics of math, including geometry. Thank you for listening to our video.
Oh, hi. Didn't see you there. I was just chilling here with my math problems. Wow. Wasn't those theorems and postulates so easy? No. So stupid. Never mind. Okay. I'm just gonna read it. A wonderful topic of angle pair relationships because it just wants to. It's the second one. It's the same. To understand special. What was that sound? Slope. Slope will be used throughout your whole math career, from algebra How'd you like my slow-mo run? It was pretty. No, wait, never mind. Whoa! Slope is used throughout your entire math career, from algebra above. Algebra above.
Try again.
Okay, ready, set, go. Hi there. As you know, slope will be used.
Your face.
Oh, hi. Now we have concluded our video. But no, I should probably say it at the end.
Thanks for watching.
Hey, like and subscribe.
Oh yeah.